Okay, getting started. So I think you see my screen, right? Perfect. So welcome everyone. Welcome to the third days of the Terraform with Azure sessions. So today we're gonna look at a little bit the advanced concept of the Terraform. So we're gonna look the modules, condition logics, and then the loops. And also yesterday we got a question about authentication. So I would like to give some information about the Terraform authentication. And also we're gonna do the too many demos about these subjects. So by the way, maybe you figure out I got a new certification. Today I passed this exam, HashiCorp Terraform Associate exam. It's the version 3. Now you can take the version 2 and version 3 also, but version 2 will be it will be an expire soon. So this is the newest version. So if you can get certification exam and if you can pass the exam, you can get the certification. The thing is, I thought the questions all about the Terraform, but not the questions of the 60%, 70% about the Terraform codes. The questions are related to HashiCorp actually. So I didn't know that. Because of that I was it was a little hard for me. And the actually codes related question was okay, but as I said, the other I don't know the other the HashiCorp the products like that they have own the cloud, they have own the policies which they call the Sentinel, and they have own repos or something like that. And some of the question is coming from this area. So if you would like to prepare this exam, so I can share with you link, guys. It's a totally official HashiCorp links, and you can the follow this the videos and the materials in there, and you can prepare the exam. And its exam is cover almost 60 question, 59 or 60 question, and you have a 1 hour. And don't be scared because it's not too long like the Microsoft questions, Microsoft exam. So the mostly it's just one line, one sentence questions, but could be a tricky because of that, the desk HashiCorp, the topics. So anyway, let's go our subjects and our topics. Yes, and so let's look at the first of all authentication. So yesterday I think the image, again, true false questions. They have 5 or 10 true false questions, and also they have some the Terraform code questions, code related, which the commands you can run, which commands when you run this Terraform plan, what will be the results, or maybe when you run when you use the Terraform Terraform cloud. So what's the expectation about this cloud or something like that questions, but it's not a huge one. So mostly the one sentence or two sentence questions. So anyway, so let's go back to our subject, which is the Terraform authentication. So I think yesterday Umit asked about the Terraform authentications. So normally in our demos, we use mostly the authenticate the Azure environment via Microsoft account. For this one, we use Azure CLI, but there's another options which yesterday I called, but we didn't, we didn't do any demo about this one. So which is the service principal authentication. So it's actually this one is the most secure, and of course this one is suitable for your the least privilege access, and you can manage this service principal of course managed by the Azure Active Directory. So you just need to create this service principal ID, and then you can use this ID for your Azure deployments, Terraform Azure deployments. And the third one also, you can use the service connection for the DevOps pipeline, pipeline. But of course, I'm going to show this one in in the tomorrow sessions for the DevOps pipeline authentication. But today I can show you how we can use the service principle. But for this one, let me share my demo environment again. So I think we can use this guy. A second. Yeah. So I think you see my screen again. So yesterday, if you remember, we had a the demo, so which we deploy VNet to VNet and peering between these two VNets. So we had variables in here, and we had Terraform TFRs, and also we had the providers in this section, and we use in the demo for the remote state files. So let's check our remote state files firstly. Containers here. Here's state file. Let's delete this one and upload the empty TF state file. Okay, done. So normally what we are doing for authenticate the Azure environment, normally we just run first of all az login comment, and we can say the tenant, and after that you just need to pass your tenant ID here, and when you press enter, it will open the browser, and you need to type your username and password. And after, if you have a multiple subscription like me, so you can set your current subscription, like a AZ account set and subscription, and then you can pass your subscription ID. But of course, this is okay for your test environment, but not ideal for the production environment. So for the production one, maybe you can use the service principle. But for this one, first of all, we need to create service principle. So let's go to the PowerShell. By the way, I use just the Azure CLI commands if you figure out. So so Terraform is not support Azure PowerShell right now. So you can just authenticate with the Azure CLI commands. So let's go to the PowerShell, and let's say let's create a service ID and new AZ AD service principle. I already used this one, AD service principle, and display name would be Terraform test app 02, and you can define a specific role. So this role is contributor. Okay, done, and you can get the no, we can go to the here, Azure Active Directory, and we can come to app registration, Terraform test app 02 is came here. By the way, you can create this service principal from your Azure portal also. Now we just need this application ID and also this certificate. So now we can use this one in a one line. So give me a second. Where's this one? So I just need to copy here. Here's my other portal. Sorry, guys. Yeah, I'm gonna share again. Give me a second. Yeah, sorry. Here. Yeah, I think you can see now, right? So let's copy this app ID. As I said, you can copy from here, or you can call in PowerShell, which is the sp.appid. So we can copy this one in Notepad. I can copy here. And then we need to get the credentials. So with the sp dot password credentials dot secret text. So this is the app credentials. So let me copy this one. And paste in the, okay. So let's go to, now our service principal is ready. So I can use this service principal for my deployments. So let's go to the R codes in the providers, and I can type in here subscription ID is this guy. Sorry. And tenant ID. Actually, Active Directory. Let's close this guy. And this is the tenant ID. And we need to define the client ID also, which is the service principal ID. I copy here. I said you can get this one from your service principal Terraform app, this one. And also we need to define client secrets. Client secrets. You can generate client secrets just one time. So you have to copy and paste somewhere. If you forget, you have to come here and regenerate. Then we can save this one, and let's run now with So Terraform init. And then Terraform I believe I saved this one, right? Save all and run again. And Terraform plan. And Terraform apply. Yes. Let's go and check our resource group. So what was our resource group name? Under RG here. And you see deployed our VNets, and we have peering between these VNets. So it works. And here come, you see who created before I did, sorry, this one. So it will become a new, sorry about that. Yeah. This one, you can see the in event log, activity log, sorry about that. It will be refresh. Yeah. Here you can see the detail. Okay, so let's go to the module. So I would like to show you a simple module. So let me share my screen. So actually Terraform module allows you to create a logical abstraction on the top of some resource sets. So in other words, we can say a module allows you to group resource together and reuse this group later, possibly many times. So let's think about we have a virtual machine in our Azure environment. So we have to define, every dependent resource for this virtual machines. For example, virtual machine itself or image. So maybe the storage, maybe we need additional storage. Maybe we need a static IP, and also we need some virtual network, subnet. Maybe we need a basic firewall, which is the network security group, or maybe we need a additional network interface. We have too many resources for creating a one VM. So every time when you need to create this resource, so you don't need to write, you don't need to create this resource again. So you can create your own modules and save in some place, in, for example, in repository, and then you can call, or maybe in your, the directory, in your file directory, and then you can call this module and you can create your environment from this modules. You can refer this module, and after that you can easily create your environment. So you can create every kind of the modules. You can create for the storage accounts, the VNets, I don't know, so maybe the VM, you can create every different, you can create the modules for every different Azure resources. By the way, not for the Azures, of course, as if, like always, as I said, you can use the Terraform environment for a different provider, like a AWS, like a Google Cloud. So you can use these modules. You can create your own modules, for another providers also. So let's create a basic demo about this one, and I'm gonna share my environment again. This one. Let's come here and let's say new folder, which is lab module, and we will create a module and then use this module. So let's say, let's create a new folder under this one and called storage account. In this folder, I'm the creating, like always, main TF file, and of course variables.tf file. So in the variable, let's create our variables. Storage name, let's say, and let's say type string, and we can say description storage account name, and let's give a default value, for example, OMD str Terraform 01. And also we can use the variable for resource group name. So type again could be string. Could be string, and let's say description here. Description resource group name, and value could be RG1. So let's create another variable for the location and copy this one. Here, let's say location, and here say North Europe. So this is my modules variable, and for the main, I can use Terraform, card providers, Azure RM, and source HashiCorp, Azure RM, and the version will be 246. So let's save this one. So you can see my modules just a storage account module. So it's similar like normal main TF and normal variables. So I just define here. Sorry, we just give the Terraform providers. So we have to create also the storage accounts, Azure RM storage account, and let's call storage on OMD. Let's say like this. And of course, name var that's str name, and resource group name is var dot rg name. Location var dot location. Account tier, let's say standard, and account replication type, let's say locally redundant storage. Let's say enable HTTP traffics only, true. I define some attributes for my storage accounts. And then maybe the last one, we can say minimum TLS version, TLS 1.2. So as I said, we have a similar main TF and variables like, we develop, we write a code, but we use this one for our the modules. And if we need to create a new storage accounts many times, so we don't need to define these ones. We can just call this module. So let's create our main TF. As you can see, this main TF not in the storage account folder. So it's in the top level, the folder, which is the lab module. So I come here, and of course, I need just copy this one. And then provider Azure RM and features will be, of course. And let's create a real deployment resource group. Azure RM resource group, and the name is rg name. Let's say name demo 03003, and the location will be seconds. Just new. Okay. Location will be North Europe. So let's use our storage account module. Let's save this one. Yes, we need to type module, and we have to say the name of the module, storage account, and of course we need to show the source of the module. So our modules in the same directory, which is the modules, actually maybe we can call, no, actually don't need that. So a storage account, and also the RG name, Azure RM resource group RG name dot name, and storage account name, let's say OMD EFS STR 001. And finally, location Azure RM RG name dot location. So as you can see in here, I refer to module, and in here I have a module. So in this module, I already defined the attribute like an account tier, like an account replication type, like enable HTTPS traffic only, or the minimum TLS version. But I don't need to define in this one because this storage account will use this modules attribute. So maybe we can create one more storage account. Let's call this one storage account 2. And of course, I will use the same source. Let's copy this one. This time, of course, storage account name will be 2. So I have one module. I'm going to create the 2 storage accounts. These 2 storage accounts attributes will be the same like my modules. So let's save this guy. And let's go to the terminal. So I just need maybe log in again. And then I need to choose my subscription. In variable where you said I could. Notes. Yeah, here, right? Here and here. Okay, then. Let's save all. And let's run the Terraform init. I'm not using the remote backend or remote TF state file. So let's run the Terraform plan. And let's deploy Terraform apply. So it will be create 1 resource group and 2 storage accounts. It's done. Let's go to our resource group and check. Demo 003 came here. Let's refresh. Yeah, 2 storage accounts come here. So let's check. And we define the minimum TLS version 1.2. It came here. And HTTP access, I believe, somewhere in here. And what we said also, locally redundant, and standard. And HTTPS must be some here, I think maybe in permission or somewhere. Anyway, it's come this one also. And then points must be somewhere here, but configuration maybe. No, it must be in here. Secure transfer record, sorry, this one, HTTPS. And this for the 01 and the same for the standard locally redundant version 1.2 and also secure transfer is enabled. So you can use your modules like this, but as I said, you can create your own modules, or if you go to the HashiCorp website or the GitHub, you can find the many templates in there. You just the copy and you just edit for your environment, but just be careful, of course, in the code before deploy your production environment. So please test it, and then you can use these modules. For example, you can create your own virtual network storage accounts, maybe the computer account. I don't know, maybe the VNet, the modules. And you can, when just you can use these modules, and of course you can use their attributes also. So let's go to the what you say again. When I create a storage account with different features, you mean attributes, right? Yes, of course, you cannot use this because in this one we have just use this attributes. So if you need, for example, let's think about for your non-prod and test environment, maybe you need a standard one, but for the production environment, you would like to use the premium, so which is the most fastest one, So what you can do, yesterday, as I mentioned, you can create the Terraform TF-vars files. And for example, you can come here, let's say account tier. Let's create account here. Let's leave this one as type, use the type. And you can come here and you can say test dot TF-vars, and also you can say prod dot Terraform dot TF. So in here, you just need to say account tier for the test one. You can say account tier AQ standard. And for the prod one, you can say premium. So when you want to deploy a different, so you just need to come here you can say the Terraform apply, of course, initialize first, and then maybe if you want to plan, and you can use the var q, for example, test dot Terraform dot tf vars comment. So for this one, you can use actually, sorry, for file, we must say, and then this one. Yeah. When you run like this, so you will have, of course, standard storage, or if you use the prod one, you will have the premium storage. So because of that, in your multiple deployments, you should create multiple TF-var files, and then you will have a different environment for your multiple environment. So if you have multiple, what does it mean? If there's a multiple modules, okay.
Yeah, if there is multiple modules, also if there is multiple prod tests for each module, is this code enough for to take the variables with prod Terraform TF-vars?
Yes, of course, it's enough. For this scenario, it's enough. But of course, for your advanced scenario, it shouldn't be enough, because maybe if you would like to create a different VMs in the different subnets, so maybe you need to define different modules, or I don't know, different modules. Actually, modules main TF you don't need to create many times, but you just need to change the TF vars and the variables. Maybe depends of your scenario. So let's go to the.
Also, can I ask a question?
Yeah, sure.
Instead of using the TF-vars file under modules, can we use TF-vars file under main accounts also?
Yeah, of course.
Also send the variables to the.
I just show an example. You can use this TF-var, of course, in your because this is not a deployment. So you're right. I just want to show an example. So you need to put this one in here. Normally. In here, because when we run this one, these comments, and if your TF-var files in this modules folder, so it's that works, of course. I just wanted to show an example. So let's go to another interesting topic, which is conditional logic. So many times we can use this one. A second, I'm going to share my screen. Yeah. So in the Terraform, we can use actually the conditional logic. So if you are familiar with the Excel logics, so you can easily understand this one. So if you are using Excel, and if you are using if logics in this Excel, so as I said, you can easily understand. So creating logic actually within the Terraform configuration allows more how can I say, dynamic configuration creation. So this provides more abstraction and logic flow in your code. So it's important to understand the logic conditions because that can be created within the Terraform, as it provides greater reusability. So, and the logic inside the expression is called the conditional expression, and it follows format like this. So if the condition is true, the result will be the true wall. And if the condition is false, the result will be a false wall. So let's do an example and maybe you can understand better. Give me a second. I will share my lab environment again. This one, yeah. So let's go and create a new folder and let's say logic. Like this ones because I will share this one with you. Then save all. Let's create a new folder. No, we don't need, just open a new folder, which is the logic. So, and maybe we can use the same go here and use module, and we can use the storage account module in this logic. So in here we have main TF. Let's go to first variable. So we don't need this one. So we have location, we have resource group, and we have storage account. But this time, let's delete the location. And let's go to the main TF. And in the main TF, let's create Azure RM. Sorry, resource Azure RM and storage account. And what we said, storage account OND. So our name will be var.str name. Resource group name will be var.rg name. But the location will be var.location. And let's create logic in here. And let's say sorry. Yeah. And var.location, if not, use West Europe. So what we said, account tier standard. And account replication type, what we said, LRS. That's enough. So in here we have the condition logic. So we say the location, if it's not match this one, so with West Europe. If not, of course, it will be used the variable one. For this one, let's save and create our main TF. In is that like okay? Let's create this one and here. So let's create our variable maintf files, wider rm. First, we are not use any feature in here. So let's create a resource group again. Azure RAM resource group, and what we call RG name, and the name this time demo 004 RG, and the location North Europe. So this is our resource group. So let's use module, and module name is storage account, and the source will be this one, and the resource group name RG name, Azure RM RG name dot name, and str name will be OND str. I don't know, 2023. So I'm not define any location for this one, but I will be copy this one and paste here, and I say storage account 2, and this time I'm going to use another name, of course, and also I will define location. This one will be a North Europe. So normally, if you can see, I'm not define any location variables in the module, and the module main TF, I said if nothing, use the normal one, so which is it will be used the North Europe. So if it's not, if it's empty, so it will be used the West Europe. So the West Europe must be the 2023, and North Europe must be 2024. So let's save all. Let's go to new terminal. And I think it doesn't need, but let's try again. And let's say Terraform init and Terraform plan. And Terraform apply. So let's say yes. Yep. So let's come here. Let's do refresh our resource group. One. The browser. 04. Yeah. 2023 West Europe. 2024 North Europe. So maybe we can do another example for the conditional logic for the better understanding. Let's save this one and let's create another folder. Let's say logic 2 for this one. And so let's create the variables. Yes. First of all, let's build a VM variable class type. So this will be description, the OS type for the VMs, and type string, and the default, let's say for now, Linux. More variable, the location type, string, and default North Europe. So let's create a main df file. We just need to, I can copy from here maybe. Use the codes file, open folder, labs here, let's go logic. And let's create locals, which is the another variable, because I will use the multiple conditions in here. So first one for the image publisher. So this one var.os type use Windows. So then it will be Microsoft Windows Server. If not, let's use Canonical. And also image offer. Let's use var.os type. If it's equals to Windows, we'll then use Windows Server, not use into server. One more, let's say image SQ. Again, var.os type equals Windows and use, for example, 2019 data center. Not. Let's use 18 Ubuntu version 18.04. -LTS. So this is our conditions. It depends of the OS type value. So if the OS type value Windows, so it's gonna use this deployment. So the OS type value, if not Windows, it's gonna use this deployment. So let's create a resource group. We can copy from here. So let's say 0.5, and we can use r.location. We need to create a VNet for this one. It says Azure RM and virtual network and VNet. Name will be OND VNet 01. Address space will be 20.0.0.0/16. Location will be var.location, and resource group name Azure RM RG name.name. Here we need to create a subnet also, Azure RM subnet. So this subnet name under subnet 01, resource group will be the same, and virtual network name will be the Azure RM virtual network .vnet.name, and address prefix will be 20.0.1.0/24. So now we can create our network interface. Resource Azure RM network interface. So let's call this one NIC. The name we can call under NIC 01. And the location will be var.location, and the resource group name will be this. But also, we have to define IP configuration, and IP configuration name will be under IP config, and this one will be attached to ID Azure RM subnet.id, and let's use the private IP address allocation, let's say dynamic. So let's create resource. We can create now the VM. So Azure RM virtual machine. And this time we can say, for example, VM01. We're going to use the name. Let's say on under VM001. And the location will be the var.location. And the resource group, we're going to use the same. Network interface ID. So we need to say Azure RM network interface nic.id. So, and the VM size, this is a small one, standard EQS. Not finish because we need to define this VM. Image publisher, image offer, and image SKU. So for this one, storage image reference, we're gonna use, and in here as a publisher, it says we already define a condition in here. It says local dot image publisher, and also for offer, we're gonna say local dot image offer, and also for the SKU, we're gonna say local dot image SKU. Version, maybe we can say the latest. Okay, and we have to define also storage OS disk. The name of this disk will be OS disk, and the caching, let's say read and write. So the create options from image. Anyways, you can find these attributes in the HashiCorp website, as I always said. So manage this type will be standard redundant storage. And the final one, we need to define also OS profile. In here, we need to say computer name. This is the OS name. It will be not the Azure resource name. So we're going to use the computer name, for example, OFD VM01. And we have to also define username and password. Normally, it's not recommended to use this one in your configuration file, of course. This is the test environment. Admin password, let's say $SSW0RD 1234, and this one. Finally, OS profile Windows config. We can leave this one empty. So let's save. So what we say is in the variable, we say the Linux in the variable So in the main TF, we have a condition in here. So normally when I run this one, it must be created Linux VM, which is the Ubuntu server. So let's try. No, not this one. Sorry. Copy this one. And let's say Terraform init. So OS type Linux. Terraform FMT. So it doesn't like this one. So at default, right? Sorry. They're all, and let's run again. Yeah. Okay, and let's go to Terraform plan. And Terraform apply. As you can see in the plan, it will be create Linux server, because as an OS type, I define the Linux. By the way, you can write whatever you want in here. If it's not matched to Windows, so it will be automatically create the Linux server. So let's say yes. Let's come here. What's our put it again? Just group name 005. So what it says, what does it like? Stroke line 52. Azure virtual machines, okay. Platform image not found. Maybe it doesn't like VM name typo. Where is that? Azure RF virtual machines, okay. Okay. Looks like okay, but I missed something. It's not the same under what? You mean this one? Computer name. So it shouldn't be the same. Because this one is the OS name. This one will be the Azure resource name. So what you say is canonical, it doesn't like. Okay. So which means it must be canonical. Nickel, right? Does it create something in here? Yes, we have to delete this one. And let's save it. From here, our logic here, TF states, lock files, let's delete. Let's say one more time, let's try. Terraform plan. And Terraform apply. Again, what it says now, it doesn't like this one. Windows configuration is invalid. So line 52, sorry. So, okay, origination VM. And 01. So let's try this one, for example. Save all, and let's come here. Variables, PS states, and log. Select this one. So in here, let's say demo 7 and the VNet 2. The other one could be the same, I believe so. VM2. VM2. So let's save this one and let's try the Windows. Terraform apply. like Windows creating. Was it like Linux? Missed something, but let's check here. 07. Okay, Windows VM NIC and virtual network here. Windows 2019 E2S. So it looks like okay. Maybe something for the Linux, but yeah, let's look at this one tomorrow because we're tired, I believe so. And also we have one more subject, which is the loops. I didn't talk about this one. So tomorrow, let's look at the loops, Terraform loops, and also the Terraform deployment with Azure DevOps. So, and also maybe tomorrow morning I can check this code for the Linux and I can fix it and I can share with you. Something for the Linux, but interesting. Okay, let's look at this one tomorrow. Okay, I'm gonna stop the record. Thank you for joining the call, everyone. And see you tomorrow. If you have any questions, please ask.